Okay, everybody, let's get started with this voiceover PowerPoint. I'll take you through the slides, and after you can go to Moodle and go through the flashcards to see what you get. This will follow along with the fill in the blanks that I gave you guys the previous day. If you don't have the handout, just make sure you get the summaries down at the end of each section. So going through here, this starts on page 3. The scope of welding code standards and specifications is a selection process put in place by the government, requirements made by engineers and designers. A code or standard is a detailed listing of the rules. A specification is a detailed statement of the legal requirements. The main concern with welding standards is safety. Bridges, buildings, pressure vessels, and welded components follow codes and standards pretty much to keep people safe. Nobody wants to drive over a bridge with the picture that you see on the bottom of this page. A good example of government regulations is here in BC, the welding or building of boilers and pressure vessels must comply with CSA B51 and ASME Section 9, which act as an enforced law to follow for the world of welding. So when you guys are welding out there doing pressure, you must weld to ASME Section 9. Here's an example of the CSA B51 and ASME Section 9 code books. They both take extensive training to navigate. Inspectors must have one or both codes endorsed under their license to be able to test welders. The specifications are recordable items such as items and material information. Quality control usually record this information. For material, it's mill test reports, stuff like that. For rods, they'll take the ID numbers off of that stuff. The welding procedure specification can be seen as a recipe for welding. This will provide you with all the information to make a sound weld and complies with certain codes. We will look at a welding procedure specification sheet later on in Learning Task 4. And when we get back into the shop, I will give you guys welding procedure specifications according to the PWPs that you guys will be practicing. Page 4, codes and standards are used interchangeably, usually to confuse everybody. In Canada, we follow the CSA, ASME, and National Research Council guidelines. Page 5, Standards Council of Canada promotes standardization in all fields. For steel structures, there is a national building code that has a minimum safety standard for building. Cities can adopt the national code or they can develop their own code that must be at least the national building code or more. In BC, we go above and beyond and follow CSA standards. Arc welding of welded steel construction follows the CSA W59 code, and CSA W47.1 will certify companies doing welding on steel structures. So if you want to rig up and do that stuff, you have to abide by CSA W47.1, which will allow you to weld on the steel structures, and you'll have to pay the money to adopt that code into your business. CSA B51 and ASME are standards to follow for boiler, pressure vessels, and pressure piping. The ASME code is divided into 12 sections. For you guys, Section 9 is most important because this is the code that you are tested to when getting pressure certified. You can see on the screen there, Section 9 is most important for welders. That takes care of welding and brazing qualifications. So here we have a summary of need to know test information. As I said before, this summary here is going to be important for test information. And if you don't get that all in, you can probably come back and pause this as you go through it. Next section here starts on page 10 in your book, Materials and Electrode Classifications. Since there are many metals and alloys, they must be organized into groups. First step is being analyzed by the American Society for Testing and Materials. Next step is being grouped into P numbers based on weldability and composition. This system reduces the number of weld tests. So for example, if you test on 5% chrome and are successfully pass, you would be good to weld on low alloy steels with chrome content up to 5%. So working in a superheater, if you got tubes that are 1% chrome up to 5% chrome, you can weld everything in that superheater. If you get 9% chrome, that's a different test that you got to do. Electrodes, as you should know, have two classifications, the CSA and AWS. One's in megapascals, the other's in PSI. You guys have gone through this quite a bit. You work with it every day. Rods used for structural or pressure meet SFA 5.1 and CSA W48.1 standards. Fun fact for you guys, RK is not certified to these standards because they will not release ingredients info. I think it's because of the health hazards that are in the ingredients, but that's just me. And note on the screen there, note that SFA 5.1 parallels CSA 48.1. That just comes up on your test. That's why I'm going over that. Moving on. The ASME code likes to do their own thing and groups filler metals into F numbers. If you're looking to work in Alberta, they follow this code. So if you weld a 6010 7018 pipe, they will qualify you for an F3, F4 procedure. I've already started implementing this in the shop with you guys, and you guys should know about the F3, F4, the 6010 7018. The A number is for weld metal analysis, which you can look at on page 14 in your books. And here's the last summary for this section. After you're done this, I will post a flashcard StudyMate link on your Moodle so you can practice and make sure you got all the info down.